Hello everyone and welcome. So in this video we will try to make a solution for the project 1. So the first thing we need to do is to write a code that takes 3 real values from the user and do the following operations. Okay, let's try at first to take those 3 real values. As we said before, we will try to use the input function. So x equal input, and here we will make a quick message x equal right, and here, as we will see, it will give us the message and then we can put a value, right? But the problem with the input is the returned value by this function is not a real value but a string value, as we can see here. So print, there is a function called type that can return the type of a variable. So now we will try to see the type of x, and we will see that it's a string, right? It's for class string. Okay, so how can we cast it to float variable? So we will just make float, and now it will work. Okay, and we will see print type of x, and it will be a float. Okay, so we will do the same thing for the 2 other values. Float input x equal no, this is one equal right, okay, z equal float input z equal. Okay, so this for the input. Now let's move to the operations. Divide the first value by 6 using bitwise operators. Okay, this shouldn't be 6, this should be 8, because we will try this to use the bitwise operators. I try to make these operations just to practice a little bit the bitwise operators. So 6 divided by 6 will not be simple to make it with the bitwise operators, and 8 will be simple. This is why we will choose 8 instead of 6. Okay, but before that, let's try to explain something. Okay, let's come out of this. Okay, we will try to work with the binary representation. So b 0 b, for example, 1 0 0 0. Okay, print decimal b, and okay, binary bind b. Nice, and we will try to do that maybe for 4 times, and here we will make shift, right shift 1. Okay, same thing here. Here again, it's not 2. Okay, this time 3, and so on. Okay, nice. So let's start the project. So as you can see here, this is 16 and this is 1 and 4 0 on the right side, but here we have 1 but 3 0 in the right side, because the 1 here took the value of the 0. So like we make a shift of this value to the right. Okay, and this shift caused really something interesting. So we have here 16 and here 8. It's like we divided the 16 by 2. The same thing here and here and here. Okay, so when we make the shift, the last value will be deleted or ignored. So this value is these four numbers here. Okay, so with these things we will now be able to make a division by 8. So we will take a number and just make shift 3 times. Alright? Okay, let's try to do that. Okay, so let's put again here this, so x equal x and shift 3 and y will 1 2. So x divided by 2 divided again by 2 is divided by 4, divided again by 2 is divided by 8. This 2 times is equal by dividing by just 4. Okay, so so here multiple. Okay, multiple. So we will make the inverse. We will shift to the left side this time, like multiplying by 4. Okay, multiple the third value by itself 2 times using the power operator. Right, so z will be equal to z2, as easy as that. Calculate the sum of the 3 results. Sum equal x plus z plus y. Okay, so y now is not the y here, it's the y here. Okay, we could, for example, make another variable, but there is no interest to make another variable. We can just store the new value in the same variable. Okay, calculate the multiplication. Okay, m equal c multiplied by y multiplied by x, and display the results. Right, print. Okay, x, y, z, s, and m. Okay, for example, we will get 80, 20, here 10, and here, for example, 8.6. Right? Okay, so this is a problem. Okay, these operators don't support float, so it has to be int. So these are not real values, but integer values. Okay, so instead of float, we'll just give int and int, and here int, right? And now it should work. So we will get 10, 12, 60, right? So 10 divided by 8 gave us 1, which is wrong mathematically, but as I said, we did this division just to understand how we can use the bitwise operators. Because as I said, when we use these bitwise operators, for example for the shift, the last value of the binary representation will be just vanished. It will be deleted. So in terms of precision, we will not be sure of the value. We will lose the precision, right? So here 1, normally this should be 1 point something, but it's just 1. Okay, 48, that's true, because we have 12 for 3 times, it will give us 48. 16 squared will give us this value. This is the sum of these 3 variables. This is their multiplication, right? So this project actually can just help us, as I said, to understand how to use the bitwise operators. It doesn't mean it will give us correct value, because if we want to make correct values, we could not just divide by using the bitwise operators, but we can use instead division, right? Multiple the second, okay, that's this for okay, and the other things are really really good.